Hello friends, this video on application of derivatives part 27 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 26. One more question. A piece of square of T side 18 cm has to be made into a box without cutting the top by cutting the square from each corner and folding the flap to form the box. What should be the side of the square to be cut so that the volume of the box is maximum? The question says we have a square like this and we have to cut the four edges. Actually, to cut four squares from the four corners like this. We have one square, one square, one square. You cut these, you take this part out. This part is out now, right? Out. So my square is like this only. This is my square. This part is all out. This is my square. And you fold this guy. You fold this guy like this. 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 With this, if you fold, you get something like this. So this is what you get. This is a cuboid kind of thing or cube kind of thing you get, right? And you have to find this is the box, actually, you can say. I'm not sure it's cuboid or cube. So this box, I have to find the value of x actually. This is the value of x, let's suppose. Because this is the square which is cut, we have to find this such that this guy has maximum volume. So we are cutting this side, we are cutting the squares of x, all x only. So we are getting four squares from four corners and flapping it, folding it to get one box such that the volume of box is maximum. So we have to find the side of the square to be cut. Correct? That is, we have to find the value of x. First question, is it a global maxima, minima question? No. Why? Because the interval is not defined. Correct? Now, let's solve this. So, if you observe here, if this whole length is 18 centimeter given, this guy is 18 centimeter. If this guy is x, this guy is x, this guy becomes 18 minus 2x. What I'm doing is I'm finding the edges of this box. This is 18 minus 2x. Similarly, if this guy is also 18, this guy is x, this guy is x, so this side is also 18 minus 2x. And this guy is x, because this we are folding it. So if you see the sides will be something like this. One side will be x, one side will be 18 minus 2x, and the other side will also be 18 minus 2x. Correct? That is how it is. Just visualize this. Since this side is 18 minus 2x, this side is 18 minus 2x, and this which the depth I'll get, because this I'll fold it here, right? I'll fold it here. So this guy will become x. So my edges of cube will be 18 minus 2x, 18 minus 2x, and 2x. Correct? Why? Let me clear once again. This guy is 18 minus 2x. Why? Because the whole thing is 18. X is 18 minus 2x. Similarly, this guy also whole thing is 18. X, this guy is 18 minus 2x. And this particular length, because this will fold it now, this x, right? This guy will become one part of the box. So the sides of the box will be 18 minus 2x, 18 minus 2x, and x. Correct? So my volume of the box will be, all length into breadth into height, that is 18 minus 2x, two side, 18 minus 2x square into x. This is the required volume. Why I found the volume? Because we are talking about the maximum volume. So the first thing I did was I found the maximum volume. The second thing it's telling the volume of the box has to be maximum. So if this guy is maximum, I have to find the question is simple now. The question is we have to find the value of x for which this function is maximum. Because this is nothing but a function, right? Let's suppose this is a function vx. Is a function, and to find the value of x for which this guy is maximum. Now it's a very simple question. Now this function can have maximum values at turning point, then non-differentiable point, and endpoints. Since I'm talking about there's an open interval, there is no endpoint. Since a continuous function, no non-differential points, the only point is the turning point. For turning point, my v dash x has to be 0. So what is the value of v dash x here? So if you take in the chain rule, first differentiate this guy, so this becomes 1, and keep this guy constant, plus differentiate this guy this time, so 2 into 18 minus 2x into minus 2, and this guy constant. So this is my f dash x or v dash x, correct? If you solve this, 18 minus 2x is my common here, so this becomes 18 minus 2x plus, or minus actually 4x, correct? This is nothing but 18 minus 2x into 18 minus 2x into 18 minus 6x, and this is equal to 0. If you solve this, x comes out to be here 18 by 2 9, and 18 by 6, that is 3. So there are two possible values of x for which this guy will have maxima or minima, because we are not sure. So we have to find now whether at these points it is maxima or minima or inflection, and we are interested only in the maximum value, correct? So let's find v double dash x, correct? So v double dash x, if my v dash x is this guy, v double dash x, let's take this guy constant, differentiate this guy. So if I take this guy constant, 18 minus 2x is constant, and differentiate this guy, 18 is 0, minus 6x becomes 6, right? Plus, now differentiate this guy this time, 18 becomes 0, minus 2x become minus 2, and keep this guy constant, 18 minus 6x. So this is the value actually. If you solve this further, this is nothing but 18 into minus 6 plus 12x minus 18 into 2, that is 36, plus again 12x, and this is nothing but 24x, correct? And this is nothing but 18 into, I think, 144 minus 144. So now let's find this guy v double dash of 9, and also we have to find v double dash of 3. So let's find v double dash of 9. But if you see one thing here, is 9 possible? Is 9 possible? No, because if 9 is possible, 18 minus 2x is one side. 18 minus 2x is 18 minus 2 into 9, that is 18 minus 18, that is 0. Can I have a box with 0 as side length? No. So 9 is not possible altogether. Correct? Why? Because 9 is something, the moment you consider 9, this becomes 18 minus 2x becomes 18 minus 0, 18 minus 18, that is 0. So that is not possible. So I'll ignore this 9 part. So I'll find only v dash of double dash of 3. That is nothing but 24 into 3 minus 144. And this is nothing but 4 into 3 12, 3 into 6 72, minus 144, that is minus 72, and that is less than 0. Since it is less than 0, I can say that at x is equal to 3, this function has maxima value. So my sides are these values, 18 minus x, that is my sides are, I'll tell you, my sides are x, 18 minus 2x, and 18 minus 2x, correct? Now let's put the value. X is 3, so 3, 18 minus 2 into 3, that is 18 minus 6, that is 12, and this also 12. So these are my sides of the box which has the maximum volume. So what we have done here, we have this equation. We first found it is not a global maximum in a quotient, and then we have this we found the sides will be 18 minus 2x, 18 minus 2x, and x. The volume came out to be this. We wanted to find the maximum volume, so we found v dash x. We made it 0. We found the x is 3, but we are not sure whether at x equal to 3 it is maxima, minima, or inflection. So we found v double dash of 3, and that came out to be minus 72. That proves that this point x equal to 3 will attain a maximum value for this equation, that is, will get a maximum volume. So when x equal to 3, my side become 3, 12 and 12. Let's take another example. Similar example here is we have a rectangular sheet instead of a square sheet, and this is also not a maximum equation. Of this side, it is again made into a box without top by cutting of the square. So same thing here. So we have this rectangular sheet of side, let's suppose 45 by 24. Here we'll again cut 4 squares, and with these we'll fold these parts, right? We'll get one box, and the box, if let's suppose x is my length I am cutting, so this guy becomes 45 minus 2x, this guy becomes 24 minus 2x, correct? So my edges of cube will be 45 minus 2x is 1, this guy is x, and this guy becomes 24 minus 2x, correct? See, this is the box I get here. This is 45 minus 2x, this is 24 minus 2x, and this depth I'll get as x. Here also we have to find where the volume is maximum. So volume here will be nothing but 45 minus 2x into 24 minus 2x into x. Here also we have to find the value of x for which this v is maximum. Same thing we'll do here. We'll find v dash x and we'll make it 0. We'll find some value of x, correct? So here also if you, so I won't solve for you, you'll get x is equal to 18 or 5. But again also you observe here, if you take x equal to 18, 24 minus 2 into 18 becomes negative. Negative side not possible. Correct? So negative side not possible. The next possible value we can take is, so at x equal to 18 not possible because this becomes negative. 36, 24 minus 36 not possible. 5 is okay. So I have x equal to 5. Now I have to check whether this actually is a maximum or minima. So I'll find v double dash of 5, and I'll find that this guy comes out to be minus 156, that is less than 0. So that means my 5 is correct. If 5 is correct, my sides will be 45 minus 2x, that is 45 minus 2 into 5, that is 35 is one side. Then actually we are asking for the side of the square that is to be cut, so that is x only, so we need not find anything. So that is x and that value is 5, and that is my answer. चलो ये मैंने बंद कर दिया तुम्हारे लिए. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.